So, we are going to begin this course with a factoring review. Factoring is a skill that you will use often during college algebra, so I thought we should take some time to go over it. After the review, if you feel like you still need more help, let me know and I can work with you one-on-one. To factor means to write as a product. Product indicates multiplication. So, for example, if we had the number 15, we could write it as a product by writing it as 5 times 3. If you had a polynomial, like the next example there, x squared minus x minus 12, you could factor it into x plus 3 times x minus 4. So again, you're writing it as a product. Since there is no symbol between the parentheses, we know that the operation is multiplication there. So every time you have your answer for a factoring problem, you should have parentheses around each part with no symbol in between. The nice thing about factoring is that you can check it by multiplying. So go back to the example of 15. We know that 5 times 3 is a correct factorization because when we multiply 5 times 3, it equals the answer 15. So that also works with polynomials. If I were to multiply x plus 3 times x minus 4, it would equal the answer x squared minus x minus 12. And I'll show you how to do that multiplication as we work some other examples in case you have forgotten. So I've split this review into different types of factoring, and in this video we're going to cover the greatest common factor and factoring by grouping. So we'll start with greatest common factor. The first step is to find the largest number that divides all the coefficients. By coefficients, we're talking about the numbers that are in front of the variables. So if I had, for example, 3x squared minus 2x plus 1, the coefficients are the 3, the negative 2, and the positive 1. So you're going to look at those numbers, find the largest number that divides all of them. The second step says use the smallest exponent for any common variables or common expressions. So if I had an x to the 5th in one term and an x cubed in a separate term, then I would use the x cubed because the 3 is smaller. I would use the x cubed in my GCF. So the important thing there is to remember to use the smallest exponent for common variables. And then you'll multiply what you got on step 1 and 2, and that will be your GCF. So we'll practice with these two examples. Number 1, the coefficients are 16 and negative 24. So we look for the largest number that divides both of those. And you may be able to just do that off the top of your head and get 8. Let me go back to that slide real quick. Okay, so we have 8. Then we look at the variables. The first term has an x, the second term does not. So we don't have any common variables. Therefore, only the 8 is the GCF. Once you write down the GCF, you're going to open parentheses. And to get what goes inside, you divide each term by that GCF. So we're going to divide 16x by 8, which is going to give us 2x. And we're going to divide negative 24 by 8, which is going to give us negative 3, and then we close. So notice we've written a product, 8 times 2x minus 3. And that's our answer. Let's go ahead and box that in, which I would like you to do on quizzes and tests, so box in your answers. Now we could actually check that by multiplying. You don't always have to show the check. Sometimes you can do that in your head, but just so you guys can see what I'm doing here, I'm going to put a check down below. So I would distribute the 8, take the 8 times the 2x is 16x. Sorry, don't know why it keeps going to the next slide. 8 times 2x is 16x, and 8 times negative 3 is negative 24, which is equal to our original problem. And that's what we want. Now, you have to be careful though, because sometimes it might not be completely factored. Maybe you didn't think about 8 as being the greatest common factor. Maybe you decided to factor out a 4 instead. And you divided by 4 and got 4x minus 6. Well, if you distribute that 4, it does give you 16x minus 24. However, it's not completely factored because the 4 and the 6 still have a common factor. Those are both divisible by 2, and so that 2 would have to come out, and then we would divide by 2, and that 2 that came out multiplies by the 4 setting in front, and then you would still get the same answer we got to start with. So just always look in the parentheses to make sure that there's not a common factor left inside. Look at number 2. So again, we're going to start with the coefficients. 24, negative 18, positive 12. Think of the largest number that divides all of those, and you should come up with 6. Then look at your variables. In this example, every term has an x in it. Maybe I should mention what terms are. Terms are separated by plus or minus. So when we go back to example 1, 16x is one term and negative 24 is a second term. So that has 2 terms in it. On problem 2, we've got 3 terms. And all 3 terms have x, so x is in common. That means x goes in the GCF next to our 6 to its smallest exponent, which is a 2. So our GCF on this problem is 6x squared. And then we open. Now we divide each term by 6x squared. So 24 divided by 6 is 4. X to the 5th divided by x squared is x cubed. So when you divide variables, subtract the exponents. Okay. So next term, negative 18 divided by 6 is negative 3. X cubed divided by x squared is x. Again, you're subtracting the exponents there. 3 minus 2 is x to the 1st power. If the power is a 1, you do not have to write it. It's understood to be a 1. In fact, anytime you have an x, let me just go up here to the top, there's an invisible 1 in front and an invisible 1 as the exponent. Okay, back to the problem. Last term, 12 divided by 6, positive 2. And x squared divided by x squared is 1, and so that 1 just multiplies by the 2 and your answer is still a 2 there. You don't need to write any x's. And that is our factorization. Again, we could check it. All you would need to do is distribute the 6x squared, and so 6 times 4 is 24. And when you multiply the variables, you add the exponents. So you'd add 2 plus 3. Then on the next one, 6 times negative 3 is negative 18. Again, add 2 plus 1 is going to make the exponent a 3. And last term, 6 times 2 is 12. And then you would still have your x squared. And that is equal to our original. Therefore, we have a correct factorization. to make sure that it's completely factored, look inside your parentheses. You have a 4, a -3, and a 2. Those numbers do not have a common factor, other than 1, of course. So it is completely factored. So that's how you factor out the greatest common factor. The next type of factoring we're going to look at is called grouping. The only time you factor by grouping is when you have 4 terms. The first step is to always look for a GCF, and that's why we covered it first. So no matter what type of factoring you are doing, you always look for a GCF first. If there is one, factor it out. If there's not, just begin your steps. So step 1, you're going to factor out the GCF from just the first 2 terms. And rather than reading all these to you, I will say them as we work some examples. So let's go ahead and look at our first example. Number 3, notice it has 4 terms in it. Okay, that's why we can factor it by grouping. So first, look at all 4 terms. We've got a 1 in front of our x cubed, a -3, a 4, and a -12. So because that 1 is in front, there's no GCF for all 4 terms. So then you're going to just look at the first 2 terms only. The first 2 terms, x cubed minus 3x squared. So 1 and 3, we're not going to factor anything out other than a 1, which we don't need to write. But they both have x, and the smallest exponent is 2. So we're going to factor out x squared, and we're going to open, and we're going to divide each of those by x squared. So x cubed, let me go back. X cubed divided by x squared is x, and -3x squared divided by x squared is -3. Close. So you just factor the GCF out of the first 2. The second step is to pull down the sign that's on the 3rd term. So in this example, that's a plus sign. Go ahead and write that down. Then the next step is to factor the GCF out of the second 2 terms. So 4x minus 12, the GCF there is 4. We cannot pull an x out since 12 doesn't have an x. So just 4 and open. Divide each of those terms by 4. 4x divided by 4 is x. -12 divided by 4 is -3. Close. Notice the expression that's in the parentheses is the same in both terms, in both groups. And that's what you need to happen. You always want the part that you write inside the parentheses to be exactly the same. So now that expression, x minus 3, is common to both terms. It becomes the new GCF. So you pull it out. So you're pulling out x minus 3. Now it has 2 terms in it, therefore you must put parentheses around it. And that's the GCF. Then you open. Divide each term by x minus 3. So this first term, this whole term is x squared, x minus 3. And if I divide the x minus 3 out, I'll be left with just the x squared. And the second term is this plus 4 times x minus 3. And if I divide out the x minus 3 from that term, I'm left with just the plus 4. And this is my answer. Notice it's a product. Sorry, this pen I'm using, if I hover it over the screen, it automatically starts advancing. So I'm going to have to learn not to do that. Okay, there we are. So notice in our answer, the parentheses are directly next to each other. So we know we have a product, which is what we need in our final answer. The step above that has that addition sign after the first set of parentheses. Therefore, that step is not a product, and it shows you that you're not finished yet. Okay, so let's say you wanted to check to multiply two binomials together. And by binomial, I mean this first set of parentheses, it has two terms in it. Two terms is called a binomial. And of course, the second set does also. So multiplying two binomials. I use FOIL to do that, which is really just giving you an order of how to multiply the terms. You don't have to do it in that order, but all the terms need to multiply by each other. So I'm going to start with first. F for first is the x times the x squared, and that would give me x cubed. O is for outside. That would be the x times the 4. So a positive 4x. I is for inside. We multiply the negative 3 times the x squared. And L is for last, would be the negative 3 times the positive 4. It's a negative 12. We do not have any like terms to combine, so we want to compare that with our original problem. The two terms in the middle are in a different order. That's okay. As long as you get all the same terms with the correct signs on them, then your factorization is correct. Okay, let's try another one. Number 4. We're going to start by looking at all the coefficients together. 6, negative 8, negative 9, and 12. We might be tempted to say 3 divides all of those, but 3 doesn't divide 8. Or maybe 2 comes to mind, but 2 doesn't divide 9. So other than 1, we do not have a number that will divide all 4. Therefore, we're going to just focus on the first two terms, the first two. 6 and 8 are both divisible by 2. And both of those terms have an x, so x is going to go in that GCF, open. Divide by 2x, so 6 divided by 2 is 3. And xy divided by x is y. Negative 8x divided by 2x is a negative 4, close. So GCF out of the first two. Next step, bring down the sign on the third term, so a minus this time. Then we look at 9 and 12, and both of those are divisible by 3, so write down your 3. Open. Divide each term by negative 3. So it's a negative 9y divided by negative 3 is a 3y. And a 12 divided by negative 3 is a negative 4. That's why the sign is so important right there. If you're unsure of your signs, distribute that negative 3 real quick and make sure that you get back the terms that were in the original. So now look inside your parentheses. 3y minus 4 is the same, both sets of parentheses. That becomes the new GCF. So you pull it out, 3y minus 4. You only write it down once, okay? Just write it once. It does need parentheses because it has two terms in it. And then you open. You divide the first term or the first group by 3y minus 4 and you get a 2x. And the second group you divide by 3y minus 4 and you get a minus 3. So it will always turn out that these pieces that are in front of the parentheses will always go here in that second set of parentheses. It's kind of a shortcut. And you can see why it's so important that you pull down that minus sign because it pulls down all the way into your answer. So let's box that in. And of course you could check it if you would like to make sure that your factorization is correct. It's always a good idea. And so I'm going to stop here and we'll pick up the other types of factoring in another video.